Hi everyone. In this video we're going to be working on 2012 AP Free Response question number 6. Now this is the question that deals with a particle in motion, so we do have to know a few characteristics dealing with this type of question. So let's go ahead and get started. It says, when time is between 0 to 12, meaning it could equal to 0 and 12, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t is equal to cosine pi over 6t. It says the particle is at position x equals -2 at time t equals 0. This right here is the most important part of the question. And that's because this right here is your initial condition. Pretty much your starting point. And another thing that we need to notice is they gave us the velocity, which is cosine pi over 6. So we can go backwards, which is a position equation, and then we can go forwards, which is a acceleration equation. So let's go ahead and do the first part of the question. It tells me, when is the particle moving to the left from 0 to 12? Well, we have to remember, a particle moving to the left is the same thing as saying that a velocity is going to be less than 0. So it's going to be decreasing. So if it's going to be decreasing, we have to think about what does that mean in calculus? Well, calculus means that if we were to set up a number line, our velocity would be decreasing. So we're going to go first and find our critical numbers. So that's when v of t is equal to 0. Well, that's the same thing as saying cosine of pi over 6t is equal to 0. Well, cosine is only equal to 0 at 2 points in the unit circle. At pi over 2, as well as 3 pi over 2. So once you know that, you're like, oh, perfect. That means that at time t equals pi over 2, as well as time t equals to 3 pi over 2, that's when cosine is equal to 0. But the problem is the inside, there's a pi over 6, so I can't forget about that. So I have to put pi over 6 over here. Then my last thing is, we'll go ahead and solve for t. How do I get t alone? Well, I'm going to multiply by 6 over pi. And that's going to simplify to t equals 2. Pi's cancel out. 6 divided by 2 is 3. And then do the same thing here. 6 over pi. 6 over pi. Pi's cancel out. When you work it out, you're going to get t is equal to 9. So that means that if I were to have a critical number, they're 3 and 9. So my next thing is I have to put these values on a number line. 3, 9. And I have to check values between left, middle, and right. But we got to remember that they're asking us from 0 all the way to 12. And I could pick 0 and 12 because it says that it's less than or equal to. So then I'm going to pick values. On the left side, I'm going to pick 1, I'm going to pick 6, and I'm going to pick 12. The reason why I'm picking 12 is because when I plug 12 into this equation, it's going to be easier to work with. So my first thing is, well, let's plug in 1. That's going to be cosine of pi over 6. Well, you got to remember, cosine of pi over 6 is the first quadrant, which is positive, which means that this equation is increasing. Then my next thing is, well, let's plug in 6. Well, when I plug in 6, I'm going to get cosine of 6 pi over 6, which is the same thing as me saying cosine of pi. Well, at cosine of pi, pi is 180, which that quadrant is negative, that coordinate is negative 1 comma 0. Then you have to remember, cosine is x, sine is y. So at x, it's negative, meaning that this function is decreasing. And then lastly, plug in 12, cosine of 12 pi over 6, same thing as saying cosine of 2 pi. At 2 pi, the coordinate is 1 comma 0, positive x increasing. So that means that my function is decreasing from 3 to 9, which means that this particle is moving to the left. So my answer would be 3 to 9. In case the question asked you when to move into the right, you would say 0 to 3 as well as 9 to 12. And that was part A. So then we move on to part B. Well, part B says, write, but do not evaluate an integral expression that gives a total distance. That's the key word, total distance. You have to know what that means. Total distance is from some point A to some point B. You're going to find the integral of the absolute value of velocity. Well, the good thing is they gave us from point A to point B. They tell us from the particle from time t equals 0 to time t equals 6. So I'm going to plug that in, 0 to 6, the absolute value of velocity, which you have the equation. So go ahead and plug in cosine pi over 6t dt, and you're done. And that's your answer. And that right there is part B. So if you didn't know that total distance is the absolute value of velocity from point A to point B, we wouldn't have been able to get this right. Okay? So then we're going to move on to part C. Well, in part C, the question says, find the acceleration of the particle at time t. So I'm going to go ahead and find the acceleration. Well, I know velocity is equal to cosine pi over 6t. So when I find this derivative, I'm going to find the derivative of cosine. because acceleration is the first derivative after velocity. Derivative of cosine is negative sine. I'm going to leave the inside the same, but then I'm going to chain rule it, and the derivative of pi over 6t is just, hopefully you guys agree, pi over 6. I'm going to make this a little bit nicer. I'm going to bring this pi over 6 to the front. So a of t is equal to negative pi over 6 sine pi over 6t. So remember, acceleration is a derivative after velocity. So all you gotta do is one derivative, and if there's an inside, don't forget the chain rule. So then the question says, is the particle of the speed increasing or decreasing or neither at time t equals 4? Well, we have to understand what it means in order for something to be increasing. In order for a particle to be increasing, especially speed, in order for speed to be increasing, velocity and acceleration has to have the same sign. And this is going to be for increasing. So when a particle is increasing, velocity and acceleration have the same sign. So what does that mean? Well, when I plug in that time t equals 4, what they're asking me, into velocity and acceleration have to have the same sign. So they both have to be positive or they both have to be negative. Well, decreasing is when v of t and a of t have different signs. So one being positive, one being negative. And then neither would be if one of them were to equal to 0 when you plug it in. So that you're not going to get a positive or a negative number. So let's go ahead and plug in 4 into velocity first. So when I plug in 4, what I'm going to get is v of 4 is equal to cosine of pi over 6 times 4, which this equals to cosine of 2 pi over 3. Problem is, 2 pi over 3 is in the second quadrant. So I have to think about, well, what does it mean for it to be in the second quadrant? What's the value of it? Well, 2 pi over 3 being in the second quadrant, your angle looks like that. This coordinate is negative 1/2, comma, radical 3 over 2. So because it's cosine, you have to remember, cosine is x. My x value is negative 1/2, so v of 4 is equal to negative 1/2. Okay, as of right now, it doesn't really mean anything. Now our next thing is we have to figure out acceleration. Well, now we can do, well, acceleration, we're going to plug in 4. So that's negative pi over 6 sine of, plug in 4 again, but we already know that's the same thing as saying 2 pi over 3. And sine is the y value. Well, the y value is right there. So this is like saying negative pi over 6 times radical 3 over 2, which is going to simplify to negative radical 3 over 12 pi. But the thing that matters is this right here is negative as well. So both of these are less than 0, have the same sign. So therefore, the speed is increasing at time t equals to 4 because velocity and acceleration have the same sign. And in the case that you would have happened to get, let's say, a positive or a negative, that's when you get when it's decreasing. Okay? So then our last part of this question is part D. Well, part D says find the position of the particle at time t equals 4. Keyword, position. We have to know what position means. Position, when it comes to calculus, is you have to include the initial, which is going to be s of 0, plus 0 to some number. In this case, we're going all the way to 4 of your velocity. So you want to find the area between 0 to 4, but also include where you started from, which is the initial condition. So then when you plug it in, you're going to get negative 2 plus 0 to 4 cosine pi over 6t dt. And then from here, it's all about integrating. So I'm going to go ahead and integrate this. It's going to be negative 2 plus 6 over pi sine pi over 6t and balance 4 and 0. And the reason why I got 6 over pi, the shortcut, by the way, the antiderivative of cosine is sine. But because of the u substitution, you have to remember that this u flips every single time. So flip pi over 6, and that's the reason why you got 6 over pi. And then the next thing is go ahead and plug in 4 and plug in 0. So when I go ahead and plug in 4 and I plug in 0, this is what I'm going to get. I'm going to get negative 2 plus 6 over pi. Sine of, when I plug in 4, I'm going to get the same exact thing I've been working with before, 2 pi over 3. Minus sine of 0. Well, remember, 2 pi over 3, the coordinate of that was negative 1/2, comma, radical 3 over 2. And at 0, it's 1, comma, 0. So sine is y, and cosine is x. So we're dealing with sine. So a sine, this is going to be negative 2 plus 6 over pi, radical 3 over 2, minus sine of 0, which is y, which is 0. So pretty much you're going to get negative 2 plus, and if you were to simplify this out, this is going to be 3 radical 3 over pi. And that right there is your answer. So this will be the position at time t equals 4. So whenever you hear find the final position or find the position dealing with a particle, you have to include the initial. Initial plus the area between that, and you're done. Alright, so thank you guys for watching. Let me know how this video went.